Okay, so for this one, the key part on yours, it's typed in. It says at standard conditions. So it tells you your temperature. Remember, that means it's either 225 Celsius, or when you add 273.15, you get 298.15 Kelvin. So that's your standard temperature right there. And then we have G equals H minus T delta S. And we're trying to solve for this, so we got to get that by itself. So we're going to subtract delta H from both sides. And that's going to give us delta G minus delta H. And that term will disappear, equals negative T times delta S. And again, I still just want this by itself, so I'm going to divide both sides. And I don't want the negative enthalpy, I just want the enthalpy. So I'm sending the negative over away with it. So those two are gone. And so I have, and this negative, it could have also been written in the front. It's not, or even up there like that or something. It doesn't have to stay beside the T, but it's not wrong to keep it beside the T. So now all I've got to do is throw in my units, make sure those are consistent. So I have 102 minus 136.4. That whole thing is all going to be in kilojoules, just kilojoules. And then my temperature is that negative 298.15. So when I pull over my calculator, I get the screen to be covered. There we go. Let me send it back over here. There we go. All right, so I get 102 minus 136.4. And then that whole thing divided by negative 298.15 gives me that my delta S is equal to 0.115. That unit right now is kilojoules per mole Kelvin. And most of the time my S should be in joules. So I'm just going to multiply that by 1,000. In 1 kilojoule, there's 1,000 joules. And so that's going to give me 115 joules per mole Kelvin.